Good day. For those of you who don't know me, my name is Douglas Harder, and in this topic we are going to describe orthogonal vectors. So, in this topic we will introduce the idea or concept of an angle between vectors. We will describe parallel vectors and then right-angled vectors. Vectors that are at right angles to each other. Vectors that are at right angles to each other are said to be orthogonal. We will then make a few observations with respect to this topic. Now, recall that a vector can be interpreted as an arrow going from the origin, or the zero vector, to a point in the plane. Thus, if I take a second vector, notice that there's a natural smallest angle between the two vectors. Now, between these two vectors, the angle is obtuse. Here's another angle, and yet again, the angle between these two vectors is greater than 90 degrees and thus could be described as being obtuse. In this case, the angle is smaller than 90 degrees, and so it is an acute angle, and we notice that for very small angles, the vectors are themselves pointing in approximately the same direction. Now, if one vector is a positive scalar multiple of the other, so for example here the blue vector is approximately 0.5 times the red vector, alternatively the red vector is twice the blue vector, then we say that the angle between them is 0 radians or 0 degrees. On the other hand, if one vector is a negative scalar multiple, so here the red vector is approximately negative 0.6 times the blue vector, in that case we will say that the angle between them is pi radians or 180 degrees. Now, some vectors are at right angles to a given vector. So for example, here we see that the angle between these two vectors is indeed 90 degrees or pi over 2 radians. There are actually infinitely many such vectors, and we will be using this quite often throughout this course. Now, if the angle between two vectors is either 0 degrees or 180 degrees, that is 0 or pi radians, we will describe these vectors as being parallel. If, however, the angle between the vectors is 90 degrees or pi over 2 radians, we will describe them as being orthogonal to each other. Just like there are infinitely many vectors that are parallel to a given vector, there are also infinitely many vectors that are orthogonal to a given two-dimensional vector. Now, the term orthogonal comes from the Greek. Ortho means right, and gon means angle. For gon, you can think of polygon, that is, a shape with many angles. For ortho, you can remember that the person who corrects or rights your teeth is an orthodontist. Similarly, orthodox refers to the right belief. Now, if the angle between two vectors is very small, then one vector can be very closely approximated by a positive scalar multiple of the other. For example, here we see the vector u and v. The angle between them is small, and notice that approximately 2.5 times v is a very good approximation of the vector u. Similarly, 0.4 times u would be also a reasonable approximation of v. Let's consider what happens if vectors are at right angles to each other, or orthogonal. Well, the best approximation of u by a scalar multiple of v is going to be 0 times v, because any other scalar multiple of v is actually going to be further away from u than the 0 vector. And again, you can just use the Pythagorean theorem to observe this. we are going to say that if two vectors are orthogonal, then, for example, v contains no information about u and vice versa. Now, here's an interesting observation. Let's take a look at the vector 1.5, 1.2. Notice that both vectors 1.2, negative 1.5, and negative 1.2, 1.5 are orthogonal to u. So, given any vector u, if we want to find a vector that is orthogonal to u, all we have to do is swap the two entries and negate either one of those entries. Important point, however, this only works for two-dimensional vectors, but it is a nice trick that we can use sometimes. So, in this topic, we've introduced the concept of an angle between vectors and, most importantly, the concept of orthogonal vectors. The angle of a vector is some value between 0 degrees and 180 degrees. If the angle is 0 or 180 degrees, we will say that the vectors are parallel. If the angle is 90 degrees or pi over 2 radians, we will say that the vectors are orthogonal or at right angles to each other. If the angle is small or close to pi radians, then a scalar multiple of one vector can closely approximate the other. If, however, the angle is 90 degrees or pi over 2 radians, no information is shared between the vectors. Now, in the next topic, we will look at how we can find this find this angle between the two vectors. Here are some references: Acknowledgments, the colophon, and a disclaimer. Cheers!